Let's look at how to solve the following questions. Given a metal block of dimension 1.5 cm by 2.3 cm by 4.5 cm has a mass of 42 grams. What is the density of the metal? Don't get panic if you have forgotten your formulas, right? The formula is in front of you, right? So very easy. You are asked to look for the density, right, of the metal. So the value of the density of metal is given to you in four options. So if you look at the units, alright, gram per centimeter cube, you will find that the density actually is mass over volume, alright. And then what you need to do is just identify what's the given value for the mass, which is 42 gram, alright. And then the volume, okay, they give the dimension of the block. So basically is a rectangular block. So what you can do is you just have to multiply by the length, width and height of the block. So basically given value of the length or the dimension of the block, you just have to multiply them up. Alright, so it's centimeter cube. So this will roughly give you about 15.525, so you can round up to at least three silicon figures, right? And then they substitute into a density formulas, which is mass is 42 gram over 15.5 centimeter cube. So basically this is if you compute, you have about 2.70, or you can write 2.7 into single figure gram per centimeter cube, right, which is uh, A, right? So this is what you need to write down, how you solve your questions. So basically you need to know what is the formulas and identify the value for the mass and volume and then substitute into the density formula accordingly, and then you find your answer. Let's look at the following questions. You are giving the velocity time graph, and then you asked to find the distance traveled in each sections. Now the distance traveled in each section basically is the area under the curve. Alright, let's look at the following velocity time graph. In this question, you are asked to find the distance traveled in each sections. So if you look at the graph itself, the velocity time graph, the area under the curve of this graph over here is basically is the distance traveled. Alright, so the area under the curve, right, is basically the distance traveled by the object. Okay, over here you have three sections, so you're asked to find the distance traveled in each section. So you have A, B and C. Now if you've forgotten your formulas, like calculate the area of the triangle, right, so don't get panic. Okay, always remember, uh, once you know your area of a rectangle, you can always find the area of the um, triangle. Okay, so let's look at let's draw a rectangle, right? So the area of rectangle basically is given as width multiplied by length. So this is your width, this is your length. If you divided this into two parts, you can see that this is the area of the triangle. Okay, so if you divide your area of rectangle into two equal parts in this manner, basically is equivalent to the area of the triangle. So don't worry if let's say you forgotten your area of your triangle, you can always obtain it using a area of rectangle. Alright, so over here the distance traveled in each section basically is the area under the curve. So area A half. Okay, so this is uh, the base is the height. Okay, or can you define yourself, this is your W, this is your L. Alright, so it's 110. Alright, so you can see the unit itself, you know. Alright, so in left meter. Alright, you see velocity meter seconds. Alright, multiply by second will give meter, so end up the unit is meter. And then over here you find that you have 500 meter. Okay, so section A, the distance travel in section A for an object is 500 meter. Now for section B, right, the area for B is very straightforward. Basically, the area of a rectangle is 150 seconds. That means this distance, this length here, basically is 150 seconds. Right, then you multiply by the height, which is 10. So you have 1500 meter. Right, now how about area C? Basically it's half over this distance, the time over here basically is um, 150 seconds. 150 seconds. Alright, multiply by 10 meter per second. So basically again you have um, over here 5. Alright, meter. The distance traveled basically the given by the area under the curve. So we have to sum all this area. Okay, total distance travel, okay, equals to the total area, right? Which is area A plus area B plus area C. Okay, just give you an idea what does it mean by the total area over here. Alright, basically it's the total distance travel by an object. Okay, because this is the time graph of an object in motion, so the object actually travel uh, a distance, alright, in 400 seconds, and then you have to find what is the distance traveled by that object in 400 seconds. Okay, basically you in this graph we can actually obtain the distance traveled by that object in 400 seconds, which is basically you have to find the area under the curve of section A, B, and C, and then you sum them up. Alright, so this will roughly give you about 2750 meter. Right,